The next thing that we're going to do with sequences is we are going to write rules to match up with a given sequence. So these instructions says describe the pattern, write the next term, and write a rule for the nth term of the sequences. So the first one we go -4, -8, -12, -16, -20. I'd be willing to bet that the next term would be -24. Seems like the pattern is we're counting by fours, going with negative numbers. Now, to write a rule for this term, remember that write a rule. This is the first term, this is the second term, this is the third term, etc. When I write the rule, I want to be able to find the nth term of the sequence. I want to be able to plug in the number of the term to come up with the actual value for that term. So I plug in 1, I get -4. I plug in 2, I get -8. I plug in 3, I get -12. I plug in 4, I get -16. What's going on here? How am I turning each of these into that particular number? Well, the pattern I'm noticing is that if I were to take -4 times 1, that would give me -4. And if I were to take -4 times 2, that would give me -8. And -4 times 3 is -12, and it looks like that's going to work for all of these. So -4 times the number of the term would be the rule that I would write. So a to the nth term is equal to -4n. -4 times the term that we're looking for. There's my rule. The next one, 2, 5, 10, 17. Oh boy. This one is kind of tricky. Looks like I'm going up by 3, and then I'm going up by 5, then I'm going up by 7. By that logic, I would guess that I'm probably going to go up by 9 to get to the next term. Well, 17 plus 9 would be 26. So I'll put a 26 here. I'm pretty confident that that's the next term. But I'm not quite sure how to write that as a rule. So again, as you come with these rules, some are a little bit tricky. Always remember, I'm plugging in 1 to get 2, 2 to get 5, 3 to get 10, 4 to get 17, and 5 to get 26 in this case. So how do I turn these numbers into the terms that I see here? Well, let's see, 2 is 1 more than 1. 5 is 3 more than 2. This is 7 more, and this is 13 more. Again, not a great thing there, but I do notice that 1 squared is 1, and 2 is just 1 bigger than that. Okay. 2 squared is 4, and 5 is just 1 bigger than 4. 3 squared is 9, and 10 is a 1 greater than 9. Let's see if we keep going this. 4 squared is 16, plus 1 is 17. Ooh. 5 squared is 25, plus 1 is 26. Ooh. So I think that my rule might be, in order to find the nth term, I'm going to take n, the number of the term, square it, and add 1 to it. So if I were describing these terms, I would say each of these terms is 1 greater than the perfect squares. Okay. Now that's kind of a tricky one, maybe one to come up with on your own. But as you work with these patterns, at least give it your best shot. Try something, see if it works. Even if you can't come up with the equation, at least write down a sentence or a phrase saying, this is the pattern I recognize. I just don't know how to turn it into an equation. That's okay. We'll deal with it. Next example. We're working in the local pick and save and are stacking apples in the shape of a square pyramid with 7 layers. Write a rule for the number of apples in each layer. All right. So n is going to be the number of the layers that we're working with. So I've got 1, 2, 3, 4, etc., 5. It goes all the way to 7. And then a sub n, this is going to be the number of apples in each layer. So in the first layer, if I were to start at the very top of the pyramid, my square pyramid is going to have 1 apple. It's going to be 1 apple up on top, and that's it. Okay. Now, for the layer underneath it, in order to make this pyramid be a square pyramid, I would have to have, let's see, 1, 2, 3. We'll throw another apple back behind here. 4 apples in that layer. We'll sneak that on top. You get the idea. 4 apples would make up a layer that would support 1 apple, and that's a square. Okay. So 4 must be the value that goes here. Now the next layer of apples, I would have 1, 2, 3, 4, 5. Well, this, in order, imagine filling in underneath all these apples. This is going to be a 3 by 3 layer. 3 by 3, 3 times 3 would be 9. Now, if we keep this logic going, I think we notice something. 1 squared is 1, 2 squared is 4, 3 squared is 9. We're going to have 16 in the fourth layer, 25 in the fifth, 36 in the sixth, and 49 in the seventh. Oops. So if I had to write a rule to find the number of apples in each particular layer, I would take the number of the layer and I would square it. There's my rule for number of apples in each layer. Now, if you wonder how many apples are in the whole pyramid, we'll figure that out in a future video.